Okay, so the first question is, so for example, a ball is thrown vertically upwards
A
at
ball is
thrown vertically upwards
vertically upwards
at 20 meters per second.
20 meters per second.
And it asks at what time will the ball come to a momentary stop?
Okay. While it stops. We had to find, it is something that we had to find time of rise.
Yes.
So you need to use this formula. Time of rise is equal to V0 sine theta by G. Do you remember this formula?
I don't think so. I just used, my mistake was I used the main 5 equations. I used V equals V0 plus AT.
No.
That was wrong.
It's a projectile motion when the ball is vertically thrown upwards. So you have to just use the time of rise in which it reaches the highest point. So this equation I derived for you.
Yes.
So its time of rise is equal to V0, but theta is 90. With the horizontal, it is 90. So it is sine 90 by G. So V0 is nothing but 20 by G, that is 10. So it is 2 seconds. Answer.
Right. I think I got 2 seconds as well. I did that. Yes, I did that. Let me see if the book, because it's from the book. It says the answer is 1 second, but this book is weird. It might have typos.
What is the answer from the book?
The book says it's 1 second.
What is the question? Again, read the question.
A ball is thrown vertically upwards at 20 meters per second. The ball comes to a momentary stop in approximately how many seconds?
It is time of rise. It is this. It is 20. It is 10. It's 2 seconds is the answer.
Yeah, I believe it's 2 seconds.
So why should he give the wrong answer?
I've done lots of problems from this book, and sometimes I think it is wrong sometimes.
Okay, now let's go to the next problem.
Okay. Okay, so this is a conceptual question.
Okay.
It says, okay, so a ball is thrown 40 degrees below the horizontal at 4 meters per second. It asks for the vertical component of the velocity after 0.5 seconds.
Okay. A body is thrown, yes?
Yes.
Repeat the question. A body is thrown.
At 40 degrees below the horizontal at 4 meters per second. After 0.5 seconds, the vertical component of the velocity is?
Okay. What is the horizontal component of velocity? That is 4 cos 40. What is the vertical component?
4 sine 40.
Yes, that's good. 4 sine 40. Acceleration due to gravity is downwards, right?
Yes.
So what is the final vertical velocity? That is V0y plus AYT. Do you know this formula?
Yes. It's the final.
That is the velocity formula in the y direction. So Vy you have to find. What is the initial V0y?
4 sine 40.
Yes, 4 sine 40. Plus what is the acceleration in the y direction?
Minus 10.
That is 10. What is t?
0.5.
Here I write positive sign. You want negative sign for this?
Yes.
Okay. I don't bother. Minus 10. But there you have to write this also negative. Why? Because it is also downwards direction.
Yes.
Isn't that? So I took this positive and this positive, that will make me that will make the same answer. V0 is equal to minus 4 sine 40 minus 5, because when you multiply 10 to 0.5, it's 5. So what is sine 40 equal to?
Sine 40 is 0.64.
0.64. Okay, I take your word. It is 2.5 minus 5. It is minus 7.56 answer. Okay.
Yes.
What is the answer?
It is, yes, it's 7.5. Yes.
That's right. Okay. You understand what I did?
Yes.
Vy, initial Vy, in acceleration in y direction and time.
Yes.
Everything was given to you.
Mhm.
Okay. Any other question, please?
No, not yet.
Okay. Continue doing these things so that you understand, and you do a lot of practice with the questions. So
Yes.
what else you want me to do?
I was just wondering if we could do just Newton's laws and Newton's law of gravitation, because I've studied them before.
Newton's laws.
Yes.
Okay, let's do Newton's laws, and then Newton's law of gravitation is second lecture. Newton's laws. Okay. First, Newton law. If there is no force, no net force on an object, then the object will have constant velocity.
Yes.
In other words, in the books it is written as, if there is a body continues to be in the state of rest or uniform motion if there is no external force.
Yes.
A body continues to be in the state of rest or uniform motion if there is no external force. It is the same thing as this. So mathematically, if F net is 0, V velocity of the object is constant.
Yes.
Mass of the object, mass is also should be constant. This is the first law.
Yes.
Means if there is no force acting on the object, then the object velocity will remain
Constant.
That is all. That is the essence of the first law. But the mass of the object should also remain
Constant.
constant, because the object, generally when you have objects, discrete objects, rigid bodies, their mass remains constant. Okay, let me explain it further. Now if F is 0, means there is no external force. Net external force is 0. There may be forces, but total net of all those forces should be 0. Then velocity is constant. If Fx is 0, velocity in the x direction is 0, what you write?
Yes. Velocity in the x direction is constant?
Yes, then Vx is constant. Good. So every vector equation is 3 equations that I have already told you. If F is 0,
then Vy is constant.
Constant. If Fz is 0,
Vz is constant.
Vz is constant. This means, suppose Fx is 0.
Yes.
Is Vy constant?
Fx is, Not necessarily.
Not necessarily. That's right. That's right. That's right. So you have to understand everything in its right context. If fx is 0, only then this velocity is constant. If Fy is 0, then only this velocity is constant. If f, you understand my point?
Yes.
And if Vx is constant, then what's Ax?
AX
What is actually the x direction?
constant? No.
0.
0.
When velocity is constant, then acceleration, there is no acceleration. After all, what is acceleration?
Change in velocity over
Yes.
time.
If velocity is constant, acceleration is 0. Here, Ay is 0. Here, Az is 0. This is all about first law. Is that right?
Yes.
Then let me go to the second law. Second law says if there is force, what will happen to the object? If there is force, if there is net force on the object, net force on the object, then what happens? Then yes, if there is net force on the object, then
object, the velocity is not constant. Velocity is
yes. To that means what you have understood so far. If there is force, velocity has to change, but not exactly. If there is net force on the object, then momentum of the object changes. Momentum of the object changes. Right?
Yes.
The force is equal to rate of change of momentum. Is equal to rate of change of
momentum.
Momentum and the direction of the force. Direction of the force is the same as what?
The direction of the force is the same as the direction of the
direction of force. The direction of force. But the force is equal to change in momentum.
Right.
Force is equal to change in
momentum.
Momentum, rate of change of momentum. So what should be the direction of the force?
The direction of the momentum. Oh, if the force is equal to rate.
The direction of the force is the same as what?
As the direction of the momentum.
As the direction of, yes, direction of change in momentum. Not momentum, change in momentum.
Oh.
That is second law. Let me explain a bit. The second law, let me explain.
Yes.
Law is simply if you apply force on an object, then the momentum of the object will change, right?
Yes.
And the force that you apply is just equal to change in momentum of that body in 1 second.
Yes.
1 second में उसका momentum कितना change होता है? That is the applied force. And the force direction is the same as the direction of change in moment, right?
Yes.
Let me explain you a little bit. Have a look. First of all, net force is equal to change in momentum delta P by delta T. This is rate of change of moment.
Right.
This force is equal to rate of change of moment. Okay. Now, what is the direction of the force? Whose direction on the right side?
The momentum. Change in momentum.
Change in moment. Yes. The direction of force is the same as direction of change in moment.
Right.
Now, suppose the momentum of the body changes by 2 units in 1 second. Yes. What is the force?
2 units in 1 second. 2?
Yes. Suppose the momentum changes by 4 units in 3 seconds. What is force?
1.3333.
4 by 3, you must say. Because Formula is change in momentum in 1 second. Suppose momentum changed by 100 units in 10 seconds. What is force?
10.
100
10,
by 10. That is 10. Is it right?
yes.
Basically, how much momentum changed in 1 second, that is the force.
Correct.
Because the job of a force is to change the momentum.
Correct.
Okay, now see, have a look. So F force, net force is equal to rate of change of momentum. That's momentum change in 1 second. And force direction is the same as momentum change direction.
Yeah.
If I can write it, so this is the basic law, right? What is the special case of this law? Special case. If m is constant, mass is constant, this will reduce to the first law then, right? Because in the first law we said mass is constant.
Correct.
So F is equal to delta by delta t. This momentum is mv, right?
Yes.
If mass is constant, then what will happen to the mass? It will come?
To the front.
It will come out of the differentiation or change. It will come out of the change, because if it's constant, it will come out. So you write m times delta v by
Over.
delta t. No?
Yes.
And it is m delta v by delta t is nothing but acceleration.
Correct.
So here F is equal to ma, which you generally use. But this is good for what?
When mass is constant.
When mass is constant. Good, mass is constant. If somebody asks you, is it the second law? What is your answer? No. Second
No.
law is this. This is special case of second law when mass remains.
Oh, constant.
Suppose mass is not constant. Can you use this equation? No.
No.
Can you use this equation?
No. Yes. With the change in momentum, yes.
You can use this equation because mass is there inside. Here mass can even change. But if mass remains constant, then it reduces to this equation. So if mass does not remain constant, this equation continues to be used. Suppose there's a rocket is there. A rocket goes into the space. It ejects masses, right?
Yes.
So its mass will not remain constant. Mass of the rocket will not remain constant. Therefore, you can't use the second equation. First equation continues to be used. Suppose there's a truck. The truck has got a sand in it. And there's a hole in the truck beneath. The sand drops down. So the mass of the truck changes. You can't use the second equation. You have to use first equation, right?
Right.
So second equation can only be used if the mass remains
Constant.
that is right. This is second law. So here I will again explain you what the second law. Suppose there's a particle, it moves with a velocity, its mass is m, its velocity is v1, right?
Yes.
And you apply force in this direction. And momentum, it has momentum mv1 is the momentum, right? Mass is velocity the momentum. Why the particle will, because of this force, what will happen to the particle?
It will change direction.
It will change its momentum, right? Because of this force, it will change momentum. So initial momentum was mv1. So what will be the final momentum? V?
2.
Yes, different.
Different velocity.
It will have a different momentum, right?
Yes.
Is that right?
Yes, overall different momentum.
It will have a different momentum.
Because force affects the velocity?
Yes, force affects momentum, but it has to affect velocity here because mass remains constant. So to affect momentum, what it has to affect? Velocity.
Velocity, yes.
Momentum को change करने के लिए क्या change होना पड़ेगा?
Velocity.
Mass तो constant है. Is that right? तो मुझे बताइए final direction क्या होगा momentum का? Will the particle go like this, this or this way? Which way it will go?
Towards the middle, like 45 degrees.
it will go like this.
Yes.
So that now final momentum is this, P2 is equal to mv2. So that if you find the change in momentum, so when you connect these tips, it will give the change. This is the change in momentum, delta. If there's a vector A, this is a vector B, what is change in the vector A minus vector B? This one.
Right.
B minus A, right? Suppose this is momentum P1. This is momentum P2. What is the change?
P2 minus P1.
So what is that?
Yes, it's
Connecting the two
yes.
tips. Connecting the two tips. So it is what?
P2 minus P1.
P2 minus P1. Good. That is change in momentum. Suppose this is A. This is B vector. Can you tell me what is A minus B? Connecting the
Connecting the two
with tip at B.
connecting the
two tips.
tips. Magar final tip has to be like this. It is A minus B.
Right.
Is that right?
Yes, sir.
Okay. Now see here. Has any Kashmiri student joined? Yes. I think some Kashmiri students have also joined the discussion.
Okay.
Okay. Now see how the Kashmiri students are giving the answers. Fatima,
G.
see for yourself. Okay, have a look. Now, the same way I was doing this, you see, I told you if this is a momentum P1 and there's force in this direction, let me suppose. And now the particle has to go like this. So that when I find P2 minus P1, that is the change in momentum, that is this.
Right.
P2 minus
P1
that is delta
equals delta momentum.
delta P.
Yes.
Can you tell me what is the direction of this delta P? This one?
In the same direction as the force.
That is right. That is right. So if a particle moves like this and force is like this, the particle has to go in that direction so that when I find change in momentum, that should have the same direction as the force.
Yes.
So if this is P1 and this is, okay, this is P2. So this is delta P, P2 minus
P1.
P1. This change in momentum has what direction?
The same direction as the force.
That's it. So it can remove your misconception. If this is a body moving with momentum P1 in this direction and you are pushing it up, with a force, you feel in your mind the particle will go in this direction.
Yes.
Don't you?
Yes.
You feel if I push the particle just upwards, the particle will go up.
Right.
This is your feeling, but the particle will not go up. If you push it upwards, particle will go like this. So that the change in momentum has the same direction as the force. So particle will not go in the direction of the force.
Right.
Will particle go in the direction of force?
No.
Particle goes in this direction, like this. But when you find the change, that change should have the same direction as force. Right? Okay. This is very important, but because sometimes we feel if we push the particle in particular direction, the particle should go in that direction. The particle should go in that direction. But that's not true. That's not true. If you push a particle in some direction, the particle may not go in the direction. Particle will go in a different direction so that the change in momentum has the direction of the force, right? See here and see here also and see here also. Should I explain it again?
No, I got it.
You got it?
Yes.
Okay. So this is the base equation. Force, net force is equal to rate of change of moment. In differential calculus, it is F is equal to dP by dt, differentiation of moment. This equation should be used when calculus is needed, and this equation should be used when calculus is not used. And also, if mass is constant, then you have simple equation F net force on the object is mass into acceleration. This equation you have been using quite often, but now you know the basis of this equation is F is equal to ma, right?
Yes.
But here important thing is mass should remain
Constant.
Does mass remain constant here?
No.
Not needed, not needed. But here it is needed that if you write this equation, mass should be constant. Is that right?
Yes.
Okay, let me go to third law of motion, Newton's third law. What is Newton's third law? It states that to every kind of a force, there is a reverse force. For every action or force, for every action, there is a reaction. That is, forces exist in pairs. This force, this law ensures law of conservation of momentum. Momentum conservation के लिए यही law जो है responsible है. Statement याद रखो आप, ठीक? For every action, there is a reaction. That is, forces exist in pairs. This law ensures law of conservation of momentum. Have you written this statement? Have you written this statement?
Yes.
Yes.
Okay. Now see what I will do. I want to explain this. Let me explain this. You imagine any kind of force. Any kind of force you imagine. So what are the forces that you can imagine? You can imagine, okay, gravitational force, frictional force. You can have, okay, contact force. You can have what you call is that tension force. You can have electrical force. Can have magnetic force. Yeah, you can have normal reaction, contact force. Normal reaction contact force में आता है. चलो, let me go to the okay, gravitational force, right? Let me say gravitational force. Gravitational force exists between two bodies. Suppose body of mass m1, it's a body of mass m2, right? This body attracts this body with a force, okay, F. When this body attracts this body, this one, this body attracts the another body. You must immediately think that this body is also getting attracted in the opposite direction. You can call this action and you can call this reaction, or you can call this action and this reaction. So if some body creates a force on another body, the body itself also gets that amount of force in the opposite direction.
Yes.
Okay, now see here. It is one example. Suppose it is Earth here. It is an object. This Earth attracts the object downwards with mg force.
Okay.
This Earth also gets attracted in upwards with the same amount of force. It is mass which is less that gets it accelerated downwards. Its mass is huge. That's why its acceleration is negligible. So it is not the Earth which is pushed up. It is the object that's pulled down. Okay, now see here. Now it is a wall here. Okay, one more example. Suppose it is a body. and you are the person here. You are pushing it in this direction. This by hand, you are pushing it by hand, this body. When you push it, you also get pushed in the back direction.
Yes.
Okay, just a minute. I will continue to give example till you understand. Now see here. These are mass Q1 charge, it's Q2 charge. This charge repels this charge.
Right.
When this charge repels this charge also gets repelled in the opposite direction by the same force.
Mm-hmm.
This is action and this is reaction. But to every action, there's equal and opposite reaction.
Yes.
If I push somebody in the forward direction, I will get pushed in the backward direction.
Yes.
Now see here. Okay. This is an object. This is one more object. Okay. Let me take these two objects. I am pushing this object, M1 object, it's M2, with force F. Who is pushing this M1 with F force?
Anybody.
A person.
Yeah.
How much force I give it?
At least as much as M1 and M2 need.
No. Leave about M2. I am not exerting force on M2. I am exerting force on M1.
Okay.
How much force I give to M1?
MA.
How much force I give this M1?
To overcome frictional force.
No. You are not understanding me and you are not giving me the right answer. Okay, I will tell you. I am giving this M1 force F.
Right.
Okay. Can you tell me how much force this M1 creates on me?
F.
The same amount if it doesn't move.
Same amount in the back direction.
Right.
Right? Okay. Now, can you tell me how much force? Okay. Can you tell me who creates force on M2?
M1.
Yes, that's right. Good. Because M1 is in contact, M1 creates force on M2. Can you tell me how much?
Is it the same, the force that the person is putting on M1 plus?
No.
Okay.
No. So now starts the, what I should say? Now starts a series of misconceptions. Now you see, okay, let me see how you think. Okay, let me see how you think. Let me tell you how you think. See how you think. You said F is created on M1, right?
Mm-hmm.
Then you say it transmits through to M2 as if it is something like that it transmits. There's nothing like transmission. There is only M1 is in contact with the M2. So whatever anything has to be done, it will be done by M1 on M2. There's nothing M2 has anything to do with this F.
Right.
So misconception, human mind is quick to get misconceptions. You feel something F is pushing and both the masses are pulling in the forward direction. So F has to do something with M2. This is quite natural way of misconception builder.
Right.
But please, you listen to me. It is M1 which creates any force on M2.
Mm-hmm.
And let me say that, okay, that is F, whatever, FC, contact force.
Mm-hmm.
Now tell me, if M1 creates FC force on M2, how much force M2 creates on M1?
The same FC.
In which direction?
The opposite direction, so towards the left.
Yes. So it is this, FC. Now I may ask you a question. This FC acts on what?
FC acts on itself. M1 or just contributes in motion.
Yes.
So
So
FC G.
let you listen. This FC acts on M2
Mhm.
and is created by M1 on M2.
Right.
This FC is created on M1 by,
M2.
yes. Now let me ask you a last question. What is F net on M1?
Net on M1 is both the force, the reaction force from FC and the force from the person.
Okay, write it down. What should I write?
F minus FC.
That is good. That is good. Now you are understanding. What is net force on M2? Yes.
On M2 is FC. C.
Yes.
Okay, so if F is acting on
What is net force on M2?
FC minus
Yes.
FC FC minus F.
No, that is not that is not good. Only FC. Now see, इसमें तो FC force है. आप ये F की बात करोगे तो that is acting on M1. आप इस FC की बात करोगे that is acting on M1. The only force acting on M2 is FC.
Right.
तो ये आपको पूरा क्लियर करना पड़ेगा. ये अगर आपको मैकेनिक्स करना है अच्छी तरह से तो then it is very important. Then it's very important to do these things. And oh, sorry, what happened? Yes, are you there?
GG.
Okay, so you have to understand it very clearly. What are the things? Let's see. I will explain again. I will explain this problem to you. You must know action and reaction forces. What force is acting on which body? So it is very difficult. Sometimes it is very tricky to find out the force acting on the bodies. Look at this. It is M1. It is M2. You are acting a force of F. If somebody is acting force on F, and the same F will act on him. And this body will create a force of FC on this body. When this body M1 creates FC on M2, this will create a backward force of FC. So this FC acts on this FC acts on this F acts on this. And पहले सवाल का जवाब ने ठीक किया. F net on M1 is equal to F forward. What is the backward force on this?
FC. So F minus.
Two forces are opposed, so subtract. So what is net force on M2? What is that?
Just FC.
Just FC. Now, students who don't have clear knowledge, they will say on this mass M2, there are this force, this force, this force. He does not know which force is acting on which body. So what are the equations that we need to write? So good books do it like this. These two masses, they separate it in the next diagram like this. And they separate the next this. They show it in a separate way. And this FC acts on this. And this FC acts on this. And this acts on this. So it becomes clear this way. But we don't need to separate it. If you want to separate them and show the forces, so on this the only force acts. On this two force acts.
Oh yes. Okay. Yes, I see it.
Now it is clear.
Mhm.
You,
Yeah, because there's two forces acting on M1, the person pushing it and then the reaction force from the M2.
okay.
But for M2 there's
Can
no
you write equation for this mass?
for
One thing is clear, that both will move together in the forward direction. That means both will have the same acceleration A.
yeah.
When you push both the bodies, they will move together in the forward direction. That is for sure.
Mhm.
Can you write equation for this mass? Yes. F is
Yeah.
equal to ma equation. Can you write for this mass?
For M1.
Yes. For M1. Yes. What do
The
you write?
force
What is this force?
M, so it's M1 times A, or
First, tell me what are the forces acting. This is the net force. What are the forces acting on this?
F and FC.
F minus FC is equal to
F minus FC is equal to M1 A.
yes, because it is acceleration is A and its acceleration is also A. So can you write the equation for the second body?
The second one, so it would be FC equals M2A.
That is good. These are the two equations that you can write. If you add them up, you can get the net force. You can get the acceleration of the system. That is very clear from these two equations. You can use these two equations to get the answer, right?
Right.
So you need to work hard on this first, so that if we go ahead, first I need whether you do a lot of work on these things.
Okay.
Should I stop the meeting now?
Yes.
Okay, you need first. I am prepared to teach you anything, everything, but there must be backup. Fatima, there must be a lot of backup from your side.
Yes.
Is that okay? Is that okay now?
जी